Alright, our first lecture is going to be putting together kind of a grab bag of geometric results that we're going to need. So let's get started. The first thing I want to do is I want to talk about the difference between a description of a mathematical object and a parametrization. If we have a line, we could describe it by writing down an equation like we see on the left hand side. X plus y is equal to 5. It gives us a way to check, is the point 0, 2 on this line? Well, let's plug in x is equal to 0 and y is equal to 2 and check if the equation is true. It's not, so that point is not on the line. Whereas it doesn't give us a method for finding a list of all the points that are on that line. For that we use what's called a parametrization, like we see on the right hand side. It says that we can write down the x and y coordinates. X is t and y is minus t plus 5, and by plugging in t is equal to 0 or t is equal to 1 or t is equal to 2, that gives us a way to get a complete list of all the points. It kind of gives us a map of that line instead of just kind of an abstract description. Now, in this course, we're going to be using notation for this. Sometimes you'll see drawing kind of a bold X to use as shorthand for x comma y. It's kind of vector notation. I would use this drawing a line on top instead sometimes, but on the blackboard that's very easy, and doing it on slides has turned out to be exceptionally annoying. So to parameterize a line, we generally need a couple of pieces of information. We need two things. We need a point, P, that is on that line, and we also need a direction vector, a vector that points in the same direction as that line. And if we have those two pieces of information, we can use that to find an equation for the line. We can say that a point on that line is given by that point plus t times that direction vector. And so, for example, for a line in 2D, this would say that x comma y is equal to some point, like maybe that point is 5 comma 0, plus t times a direction vector. That direction vector might be 5 comma minus 5, or some other point in direction vector. There's more than one way to parameterize a line, but that's the basic method for doing it. The physical interpretation for what this equation does is very straightforward also. It says that the point is where we imagine an object is starting at time 0. We imagine it starts at time 0 and it's moving with velocity vector v. And at time 5 we plug in t equals 5, and that tells us where the object's gotten to. For example, we can use this method to find the line defined by 2 points. If we instead have 2 points P and Q on the line, where say P is this point here and Q is that point over there, we need usually a point and a direction vector. To get a direction vector, we subtract them. We take Q minus P and then we plug that into our formula for the line that we had from before.